So move to the slide. Okay, so basically this one is a part number 2, but I want to do it on the part number 1 here because in Thursday you have some discussion with the data representation. That's why I want to move it to the part number 1 here. So for the data representation, what happened?
It's on these other monitors here.
Sorry?
It's on the second. These two
TVs
here.
Oh, okay. Okay. So I think I have to animation. Why stop slideshow? What happened? See what happened.
When you moved it to the right there, it went to the other TV.
This one?
Yeah, up to the left there.
Question. One, two, three. Here, right. Let's see. I have one, the same. Oh, this is one. No? Why? Confusing. Okay. What happened? It's okay now, but it's not okay anymore. Stop.
Is there a way you can turn that TV off?
I don't know. I don't know how to turn on. I don't know. Let's check. So I want to duplicate here. Hi. Where? Nowhere. See? Oh. Click the setup here. Press change for me. Okay, so anyway, I can do like this one. So on the chapter 2 here, we do with the data representation. Where's the Zoom meeting? Okay, so the first thing we talk about is decimal and binary representation. The number system we normally use is a decimal system. Everything for each of the digits, you have the 10 value, everything from 0 to 9. But in the real life, a number can be any base. So they call the base 10 here because for each of the digit, right? Each digit you have a 10 value, everything from 0, 1, 2, and come all over to 9, the base 10. Right? But in the real life number system can use any base. And normally computer work with a binary system. Binary system, that means for each digit you only have a 2 value. You have the 2 values. What's going on? Then you have the 2 value, 0 and 1. Or other system uses the computer, it can be the octal or base 8 and hexadecimal base 16 here. Now you have the base and exponent, right? So base exponent is normally you have the 10 raised to power 2. That means the 10 here is the base and 2 here is the exponent. Right? So you can think about this, or the 5 raised to power 6. That means you have the base here, the base 5, and the 6 here is a component. And you have exception here, right? So any number when you power 0, you have number 1. The only exception is that you have the 0 raised to power 0 is amplified. Now for the decimal system, you know that you have the column, unit column, right? You have the 10 column, you have the hundreds, you have 1,000 and 10,000 and 100,000 and so on here. So So if you look on the decimal, if you look on the decimal system here, you have 1 column and 10 column and so on, right? So we see it is by 10. That's why you have the by 10 here, right? And the first column is the value of the first column. You have the 10 raised to the power of 0. The second one, the 10 raised to the power of 1, and so on. That's why this column, the value is the number 1, and this column value number 10, and 100 and 1000 and so on. Right? So basically, if you have the number 55 here, if you have number 55 here, right? Both of the digits here is the number 5, but the value is not the same. Right? You know that this one is a 1 column. That's why you have 5 here, right? You have the 5 here. But this one here in the 10 column. So actually, this one you have to time into 10 here. This one you have the value of 50 here, right? So see, if you write the number 55 here, they look the same, but the value is not the same. Right? This column here you have the 50, and this column here the 5 here. So when you understand about the number system, the first thing you have to understand about the value of each column here. This column is number 1, number 10, 100, and 1000 here. And the reason why the 1, because the 10 raised to the power of 0, you have 1. The reason why is the 10, because 10 raised to the power of 1, you have 10, and so on here, right? And so on here. Now, think about this. You have the number of the 6,825. Actually, you have to break it down with the column, right? So for number 5, you have in the 1 column. That's why you time with the number 1 here. Number 2 here in the 10 column. That's why you multiply with the 10 here, and this column 8 here in the 100 column. That's why you time it to 100 here, and so on. And finally, you just add them up together. You have the 6,825 here. That is by 10. That is by 10 here, right? Now, if you move to the binary system, the binary system, it is base 2. Base 2, that means each digit you only have the 2 values, 0 and 1 away. You will have only the 2 0, 0 and 1 away, right? And for the binary system, the way it works quite the same, right? The way it works quite the same in the binary system here. Where my mouse? Now, the way it works is quite the same in the binary system. So you see, in the binary system, instead of by 10, instead of the by 10, now you have by 2 away, right? And the column do the same. The first column, the second one, and the third one, and the fourth one, and so on, right? So see, for the first column, the value of the first column, we have the 2 raised to the power of 0. You have 1 here, right? And the second column, you have 2 raised to the power of 1. You have the 2 here. And the third column, you have the 2 raised to the power of 4. So 2, you have the 4, and so on here. It do the same. It do the same, right? 2, 1, 2, 4, 8, 16, 32, 64, and 128, and so on here. So you see, the same is this one here. If I have the number 1 and 1 here, if I have a number 1 and 1 here, right? Both of the digits number 1 and 1, but this one has the value of 1. But this one is not. This one is value of 2 here. You see, this one has the value of 2 here. So it depends on the position of the number. You have to appropriate the value of this one. So in order to convert from the binary system to the decimal number, all you have to understand is you have to know about the value of the column. That's all, the value of column. So basically, in the computer, they work with the bytes, right? The bytes, that means includes the 8 bits here. So you see, for the 8 bits, that's why you have to run everything from 0 to 7, right? Bit number 1 here, bit number 1, number 2, number 3, number 4, number 5, number 6, number 7, and number 8. Okay. So in order to convert it from the binary to the decimal, it's very simple, right? Think about, if you have the 1 here, you have 0 here, you have 1, you have 1, you have 0, 0, 0, and 1 here. Now, all you have to do that you time it to the value of the column here, right? You just time it to the value of the column. Time it to the value of the column here. So you see, you have 128 times 1, right? You have 128 here. You have 128 here. You have 0. You have 64 times 0. You have 0 here. You have 32 here. You have the 16 here. You have 0 here, you have 0 here, 0 here, and you have 1 here. And now, last thing, you just add them up together. You just add them up together. You just add them up together. You have the decimal number. So this one here, you have 160 for this one, you have 176 for this one, and you have 127 for this one. Sorry, 177 for this one. That is the way you convert it from the binary to decimal system. The most important thing you have to understand about the value of each column here. That's all. The thing about if I have the number 0 here, number 1, and I have 0, 0, 0, and 1 here. What do you think? What is decimal number of this one? What do you have for the decimal number of this binary number? Hmm?
99.
Okay, 99, right? Because you see, you have the 64 here, you add the 32, you have 96. And 2 here, you have 98, and 1 here, you have 99. Okay, that is the way you convert it. That is the way you convert it from the okay. Now, yeah, so how we convert from the binary to the decimal, right? So now, what happens if you want to convert from the decimal to the binary? What happens if you want to convert from the decimal to the binary? I'll come back to this one. Think about here. If you want to convert the number 200 here, 200 back into the binary, it follows in the reverse way, right? So now we have to do everything from the left to the right. Now, in order to have the 200, of course, you need 138 here, right? So whenever you need 138, you have number 1 here. So that means you already have 128 for this one. That's why you have to minus 128 here. 128 here. Right? So you have 72 left. Right? Now you're done with the left column. You move to the right. Now, in order to make it up for the 72, you need the 64, of course, right? You need the 64, of course. So we have the 64 here. So now we have to minus for 64. You have 8 left. You have only 8 left. 8 left here. You do not need the 32, right? You do not need the 16. You need 8 here to make it perfect, right? And of course, when you have 8 here, you minus 8. You have 0 left. So when you have 0 left, you put 0 here. 0 here. So that's why when you convert from the 200, you convert it back to the binary. You have 1 1 0 0 1 0 0 0 here. Right? It's very simple. It's this one. Any questions so far? Hello? Okay, so here's the same, right? If you want to convert the number 172 here, you move from the left to the right, you need 128, right? And you minus 128, you have the 44 left. 44, you do not need 64. That's why you put 0 here, and so on. That is the process. Now, in the computer, it also uses a hexadecimal system. In the hexadecimal system, it is by 16. It's by 16, not by 2, not by 10. By 16, that means for each digit, it has the 16 value. It has 16 value. So in the hexadecimal, it has for the base 16 here or the hexa here. That means the 16, right? In the base 16, if you have 1 digit, you have the 16 value. You have everything from 0, 1, 2, and all over to the 9. And after that, you have A, you have B, you have C, you have D, you have E, and F here. So you can think about this one here. A is the 10, B 11, C 12, D 13, E 14, and F 15. Right? So see, if you have everything from 0 to 15 here, actually you have the 16 value. That's why they call it the base 16, or they call it the base hexa. Hexa, that means 16 here. Right? So the way it works is quite the same. The way it works is quite the same here. You can think about this one. The way it works quite the same. Yeah. It also work with the column value, right? It also work with the column value. We think about this one here. The first column here, it always 0 here, right? The second column, number 1, number 2, number 3, and number 4, and so on here. Now, this hexadecimal is a base 16, right? That's why the value of this one is a 16 raised to power of 0. This one 16 raised to power of 1. This one 16 raised to power of 2, and so on here. Now, for that reason, you see, this one, this column here, value is a 1. This one is 16. 16 times 16, you have 26 here. Sorry, 256 here. And 16 times 16 times 16, you have 4096, and so on here. Now, if you want to convert it, back to the decimal, you follow the same. I think about this one here. If I want to convert A3 here to the decimal, what do you think? What is the decimal value of A3? If I have a hexadecimal A3, what is the decimal value of this? What is the decimal value of this one? What do you say? How do you say?
163.
Yeah, 163, right? You have 163, and the reason 163 is that A is a 10, right? You have 1, 0, 1 all over to the 9, A is a 10. 10 in this column, the value of this column is the 16, right? That's why you have the 10 raised to 16 here. And this column, you have the 3 times 1, you have 3, right? So we add them up together, you have 163 here, right? So see, A3 in hexadecimal, when you convert it into the decimal system, you have the 163 here. Make sense? Any question? Hello? Now, what happened if I want to convert from the decimal number back to the hexadecimal here? So what happened if I want to convert the number 200 in the decimal back to the hexadecimal? What do you think? How we do it? And what is the number of the 200? What's the number of 200 in the decimal into the hexadecimal? What is it? $200 here. If you want to convert it back to the hexadecimal, what is it? What do you say? Any answer for us? If you want to convert 200 into the hexadecimal, what is it? Now we do just follow the same, right? If you follow the same, you move everything from the left to the right. You do not need such huge number, right? That's why you don't need to put anything here or put 0 here. You do not need this one, right? You don't need 256 to make it up for the 200 because you need 60 here. Right? But in order to make it up for the 200 here, how many 16 you need? How many 16 you need? What do you think? How many 16 you need to make it up to the 200? What do you think? Yeah, 12, right? And of course, 12 in the hexadecimal, it is C, right? C here, that means 12. 12 in hexadecimal. So see, when you have the 12 of the 16, you see 12 of the 16 here, you have the 192 already. 192. So we minus it 200 to minus to 192. You have 8 left, and of course this one is 80. So anyone with answer C8 is the correct one here. It clear now? Okay, so basically it is a C8, not SC, right? C8. Okay, so in the hexadecimal, all right, you see, you have everything from 0 to 9, and 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 here is F. That's all. Okay, so in convert, right? Convert here, you do the same. You follow up the process. You do everything from the left to the right. And see, if you want to convert 875 here, you need 3 of the 256, right? So remember 107 here. 107, you need 6 of the 16, right? So remember you have the 6. Sorry, remember what is the remainder? Remainder it is 11, right? That's why you have B here, right? That is the process we convert it. If you convert from the hexadecimal to the decimal, you do the same. If you have 1, 2, 3D, this column here 4096, this column here 256, this column here 16 and 1, and you just times them together, right? You just times them together, and you add them together. And you have the 4669 here for this one. Okay, and one more way is that it's easier. I think it's easier when you convert from the hexadecimal to the decimal or the binary. It is using the hexadecimal notation here. It's very simple, right? So you can think about this one here. You have 0 here in decimal. When you convert it into the binary with the 4-bit, you have 0, 0, 0 here. You have a 1, you convert it into the binary with the 4-bit. Binary with the 4-bit, you have binary with the 4-bit, you have 0, 0, 0, 1 here, and so on here. And of course, when you convert it to decimal, 0 is the same, right? The 7 is the same. 9 here is the same, but 10 here in decimal, it is A in hexadecimal. 11 here is a B, 12 here is a C, and so on. So when you understand about the hexadecimal notation, it's very easy for you to convert it into the binary or into the hexadecimal system here. So think about if I want to convert it here, right? If I want to convert the number A and number 7 here, if I want to convert A number 7 here from the hexadecimal into the binary here, right? So if you want to convert from the hexadecimal to the binary, you just break it up into every single digit of the hexadecimal. You know that for each of the hexadecimal, you need 4 bits. You need the 4-bit because see, for each of them you have the 16 value. You know that in order to represent 16 value, you need the 4-bit because 2 raised to the power 4. You have the 16 here. So see, A here, what is A? You look it up on the A here. You have 1, you have 0, 1, and 0 here. That is A. And the 7, what is the 7 here? You look it up on the 7, you have this one. You have the 0 and you have 1, 1, and 1. That's all. That when you will convert from the hexadecimal to the binary, you just break it in the group of the hexadecimal, and you convert it with the hexadecimal notation here. The same. If I want to convert from the 0, 1, 1, 1, 0, 0, 1, and you have 0, 1, 1, 0 here. I want to convert it back to the hexadecimal. What do you think? What I have here? What I have here? What do you think? As a group, every 4 bit is one hexadecimal. I just converted back, right? So we have 1001 here. This one, right? So I have 9 for this one. Now what is it? You have this one here. What here? You have this one, right? You have 6 here. Yeah, that's all. That's why you convert from the hexadecimal to the binary, and then I reverse one. Okay, so see, when you convert from the binary to the hexadecimal, you just group every 4 bit together. You just group every 4 bit together, right? So think about this one here. You group 4 bit here, you group 4 bit here, you group 4 bit here, and you group 4 bit here, right? This one here, 1 1 1 1. You know that is F here, right? That's why F, and so on. Now, so you may raise a question here. So how the computer represent the integer number? So if you want to press a number 3, or you want to press a number negative 15, so how computer represent it? That is the way you learn it on this class here, right? So how computer process number depend on each number type. So the way it stores the integer number and the way it stores the float number is not the same. Because you know that integer number is a whole number, but in the float number you have the float decimal part and fractional part here. Right? It's not the same. And so what's the integer number? Remember that integer number is always a number in the whole number only, right? So you can think about number 1, number -5, or number 10, they are integer number. But you think about that 2.0 here, it's not integer number, right? Because you have both of the decimal part and fractional part here. So integer can be stored as an unsigned number. Unsigned number, that means they are non-negative number. You cannot have negative number here. It's one unsigned number. Or signed number. In signed number, that means you can have the both the positive and the negative and the 0 number, right? Also, floating point number, also they have many, they have several variations. But in this class, I think we just study about the integer representation in the computer. Now, the first one is unsigned. Unsigned, that means it's not non-negative, right? It can be 0 or positive here. So computer process information in the form of byte. You know that 1 byte, that means you have 8 bits here, right? So byte are normally it's 8 to the 16 bit or 24 bit, whatever it is. It always it's multiplied by the 8 bits here, right? So from the computer point of view, to the store number 1 in binary or 101101 here, they both have need to the same length of byte here. Right? You see, it only work with the byte here, right? So even that, if you want to represent only the 1 here in binary, the computer also it has to reserve for the slot of 8 bit here. It will the same. And in this one, you 1, 2, 3, 4, 5, 6 here, it also reserves 8 bit for this one. Right? So even that, this you only need the 2 digit, and this only needs a 5 digit. But from the computer point of view, it needs to reserve 8 bit in order to store it here, right? So to do this one here, from the computer point of view, right, to store the number 1 and 1 here, in order to make it up for the 8 bit here, it adds all of the 0 to the left here, right? So see, you already have the 2, number 1 on the right here, you just add it up with the 6 bit of number 0 on the left to make it 1, right? And the same as this one, you need to add it up to the 3 number 0 on the left here. So that is the way computer store the binary number into the byte here, right? And this is called the unsigned form of integer. Unsigned form, that remember that unsigned form, that means it is a non-negative. It can be 0 or positive number. Now, to unsigned binary integer, to store the number, to store the decimal number integer number right here in the byte 10 and the 8-bit memory location. Right? So in the 8-bit memory location, it's very simple. You just convert here number 5 into the binary. So you see, you have convert number 5 in memory. You have the 1, 0, and 1 here. Right? And if you want to store it in the 8-bit memory location, you need the you need the 5 bits on the left here, right? That's why you add the 5 bit in the left. So in total, make up 8 bit here, right? This one is number 5, and you add the number 0 on the left here. Now, if you want to store the decimal integer here, 928 here, in the 16-bit memory location. So when you convert it to the binary, you have this one, right? You have this one, but remember, you need to store it in the 16-bit here, right? So of course, you need to add the 0 here on the left to make it up for the 16-bit here, right? And any questions so far? Hello? Any questions? Now, in some cases, you will have overflow. Now, what happened here? Think about. What happened if I want to think about this one here? What happened if I want to store the number 23 in the 4-bit memory location? I cannot do that. The reason is that 23 here, when you convert into the binary, 23 here, when you convert it into binary, you need the 16. You need the 16 here, right? You need 23, right? You have 0 here, 8 here. You need 4, 16, and 8. You have 4. You have 1. That is 24. 23 here, right? This one 16. This one 4, 2. No, 4, 2. No, this one 4, 8, 16 plus 7, right? Plus 7. Okay, so my mistake here. So we have 0. You have 0 here. You have 1 here. 16, right? So this one you see, you cannot store it in the 8-bit memory. It already 5 here, right? So in that case, they call it overflow. Overflow, that means you do not have enough bits to represent the number, right? So think about this one here. If you want to store the number here, 65,537 into the 16-bit memory also, you cannot do it, right? Because you got the overflow here. So that is something you remember the definition of overflow. Overflow, that means you do not have enough memory to store the number. I think that you in the exam you have the question to ask you about the overflow. Okay, so here's the range of the unsigned integer number here. Right? If you have the 8 bits here, I see. If you have 8 bits, that means you have 2 raised to the power of 8. You have 256 value, and it range everything from 0 to the 255 here. Right? And if you have the 16 bits, that means you have 2 raised to the power of 16. It ranging everything from 0 to the 65,535 here, and so on. So it depends on the number of bits in the location. It can store in the different range of the integer number. Now, so we learned about the unsigned already, right? You learned about that. You learn about unsigned already. Unsigned integer, that means it is a non-negative. It can be 0 or positive here. Now, in sometimes you need something with a negative number, right? In the case of the negative number, you need to use a signed number here, not unsigned anymore. Right? So in that case, you have the size and magnitude format here. That's a simple method to convert a decimal integer into the binary, right, to represent the positive and the 0. It's very simple for the unsigned, right? See, it's that converted normally. But what happens if you want to use a negative number? So in that, you need to store the size here, right? What happens if you want to store the negative number? You need the size here. The size and magnitude format is one way. It's only one way. Actually, you learn about the one complement and the two complement later. And the size and magnitude format is one way to represent the size, the size number here, right? And the leftmost bit is reserved to represent the size. So if you look on the size, and magnitude number here, the leftmost bit here, the leftmost bit is always reserved to represent the size. And if the leftmost bit is 0, it is a positive number. And if the leftmost bit is the number 1, it is a negative number. That's all. That's a negative number. And the other bit here represents the magnitude. That means how big the number is. Right? So think about this one here. If I have the number 0 in 0 and I have a 1 and 1 here in the 4-bit number. What do you think? What is the number it is? It is in the size and magnitude. So what is the number in the decimal? What do you think? If I have 0, 1, 1, 1 in the size and magnitude format for the 4-bit number, what is the value of the decimal number? What's the value of the decimal here?
+7.
Yeah, 47, right? So the first thing is that when you translate it here, when you translate it into the size and magnitude here, the first thing you read on the leftmost bit here. 0, that means positive. It's a positive. Now this one is number 4, this one number 2, and this one number 1, right? And when you add them up together, you have the positive 7 here, right? Now, what happens if I have the number 1 and I have 0, 1, 0 here? What do you think? What is the decimal value of this in the size and magnitude format? What do you think?
10.
No? Not 10. You have to remember this one is a size and magnitude format here. Yeah, -2 is correct. All right, now how it works? The leftmost bit here is the size. That's the leftmost bit here, the size. That means here. This one, number 1, that means negative. That's one negative. This one 0. This one number 2. This one 0 here. So you have -2 here. Make sense? Any questions so far? Okay. Okay, that is a size magnitude format. That when we do with the size magnitude format, remember that the leftmost bit is always a size. 0, that means positive, and 1 is a negative, and all of the other bits represent how big it is. Right? The absolute value of the integer. Now think about this one here. You can see the store the decimal number positive 23 in the 8-bit. So is that converted normally? Right? Is that converted for 23 here normally? So when you convert it normally into the binary, you have this one here, right? But you want to store it in the 8-bit memory, right? It's the 8-bit memory. You see 1, 2, 3, 4, 5. You need 2 0 here to make it up 7-bit. That is the magnitude. That is magnitude. And the leftmost bit, the last one here, is a positive here. That's why you put 0 here. That's all. And you see that is the put 0 here. Right? Now, if you want to store the negative 19, if you want to store the negative 19, you do the same. Forget about this one. You just convert the magnitude first, right? Forget about the sign here. So now you just focus on the magnitude. You see, in order to convert the 19 here, you have the 0. Sorry, you have 1, 0, 0, 1, 1 here, right? It already 1, 2, 3, 4, 5. You have 5, right? Now you need to convert it to 16 bit here, not the 8 bit. Right? So you have 5 bit here. You need to add 10 bit number 0 on the left. Right? On the left, bit number 0 on the left here. You need to add the 10 bit number 0. So now in total, this part here is this is the magnitude part here. Right? And now the last one, you see the number negative here. That's why you put the number 1 before that one. That's all. Number 1 here is negative, and everything here is the magnitude. Right? It makes sense? Any question? Now, for the unsize and magnitude, you have problem of 0 here. Now, see what is the problem of 0? I think it was this one. If I want to store all of the 8 bit here with a 0, if I want to store all of the 8 bit here in 0 in the 8 bit location, what do you think? What is the number of this one? What is the value of this one? What's the value of this one? 0 in decimal, right? 0 decimal. Actually, you can convert to positive 0. Getting by this one, right? 0 here is a positive, and all of the 0 here is a 0. Right? Now, if I have the 1 here and all of the 7 here 0, what number I have for this one? Negative 0. Right? The same, negative 0 here. So see, that is a huge problem with the computer. It's very confusing here, right? So you see, for the sign and magnitude here, you have problem of 0 because for one number of 0, you have 2 ways to represent it. Right? All of them 0, or you have 1 and all of the number 0 here. That's a huge problem. So normally in the computer, they do not use the sign and magnitude here. It's very, very confusing here. Right? So remember that you just need to understand about how it works with the unsized number, sign and magnitude number, but you have to remember that you have some problem with the size and magnitude. You have 2 ways to represent the number 0. It's a huge problem in the computer here. So, I see. You have any questions so far? Hello? Okay, so now let me go. I will continue with the. Okay, now we move to the one complement format here. So far we already learned something about the unsize, right? The first format is unsize here. The first format is unsize. Unsize everything with a 0 and the positive, right? The second one is a size and magnitude. My sign and magnitude that you have the left mode bit is a 0 and 1 to store the size, right? And the remaining bit is that it stores the absolute value of the number here. Now, you have another one. You have another type to represent the integer in the computer. It's a one complement format here. They try to show problem of the 2 way to represent number 0. So for the one complement format, so with the one complement format, when you work with the positive number, it works the same. You just convert it normally. And the left mode bit here is the number 0, right? But when you work with a positive number, okay, the same. It is the left mode bit is number 1. The left mode bit is number 1, but every other bit they just revert it. So from 0 they revert it to number 1, and 1 they revert it to number 0. Right? So think about this one here. Think about if I want to convert. Think about here. If I want to convert the number. If I want to convert the number 10. I want to convert it number 10 into the binary with the 1 complement here. What do you think? What I have? If I want to convert the number 10 in decimal into the binary with the 1 complement format, what do you have here? What do I have? If I work with I work with the 8-bit here. I want to convert it to the 8-bit 1 complement format. What value I can get it here? What do you think? It's number 10. I want to convert it into the 1 complement format. What number do I have? What number do I have? That converted normally. That converted normally. Number 10. So it's you have number 10 that you need 8 here. You do not need the 4. You need the 2, and you have 0 here. Right? And now for the 8-bit, you need the 1, 2, 3 here. And you see it is a positive. Right? So the last mode bit here 0. That's one. Right? So that when you convert the number 10, the positive number 10 into the 8-bit 1 complement, you just convert it normally. And you add it to 0 on the left here. But what happens if I want to convert number negative 10 here into the 1 complement? What do you think? What's the number do I have here? What's the number do I have for this one? What do you think?
Is it 1 and then 1, 1, 1, 0, 1, 0, 1?
Yes, right. So think about this one here, right? The negative, that means the left mode bit here, number 1, right? Now, for all of the remaining bit here, you just reverse it, right? So the number 0 here, you convert it to the 1, and number 0 reverses to number 1, 0 reverses to number 1, 1 reverses to number 0, and 0 here reverses 1, and 0, 1 here, right? So that is the way you work with the 1. You work with the 1 complemented format here, right? So see, if you want to convert the positive 37 here into binary, right? And this is an 8-bit location, right? So you see, you need the left mode bit here, number 0. You just convert it 0 and normally and add 0 here. But if you want to convert the negative 33 here, right? You see, to negative 33. So you see, for this one, you have to number 1 here. It is what is it? Oh, this one is 2. Oh, sorry. Yes, my mistake. Yeah, sorry for that. I missed something here. I missed something here. What is it? Let me clear it. Yeah, I think the same. Yeah. Yes, to do the same here, right? Why? I think the slide here, something wrong with the slide here. Yeah, sorry, something wrong with the slide here. Okay, something wrong with the slide. Something wrong with the slide here, right? Now, but for the 1 complement format, again, you still have the problem of the 0 again. Now, think what happened here. If I have the 8-bit, if I have the 8-bit number 0 here, what do you think? What's the value I have for this one? 8-bit number 0 here, positive 0, right? The thing is that here, you look on this one, 0 here, that means the positive, right? And you see, everything here is when they are positive, right? You just keep it the same. You have 0 here, and you convert all of them, you have positive 0 here. But if I have all of the bits number 1 here, you have all of the bit number 1 for this one here, right? 8 bit number 1 here. Now, what I do, you look on this one here, right? You see, when you look on this one is number 1. So I know this is negative. And you know that in the case of negative, in order to find it, you have to reverse it. You have to reverse it. That's why you have to revert it to 0, 0, 0, 0, 0, 0, 0 here. So you see, you have the negative 0 if you have all of them number 1 here. So again, you see, with the one complement format, you have the problem of the 2 way to represent number 0. It's really confusing, right? So again, so see, so up to now you learn something about the unsigned format. You learn about the size and magnitude format. You learn something about the one complemented format. But we see with the size and magnitude and with the one complemented format, you all got the problem of 2 ways to represent number 0. Right? So basically, in the computer, in order to do with the present of the number 0, they use a 2 complemented format here. So what is a 2 complemented format? 2 complemented format. To find the 2 complemented format of x bit number, if the number of the positive do the same. Remember that whenever it's a positive, it always do the same. Even if it's a signed number or unsigned number or 1 complement or 2 complement, it always the same. It's just converted normally, and the last word is 0. That's all. Right? Now, if the number is negative, right? If the number is negative, you have to convert the number into binary. And the first step, you have to find the 1 complement of that number. That's the first step, right? Now, the third step here, you have to add the binary number 1 to the 1 complement of the number. So when you find out the 1 complement, you just add it to number 1. And if the result is extra bit, that means overflow. You have to discard the leftmost bit from that. And all of the process here help you to fix problem of the 2 way to represent the number 0. So now, what happened here if I want to convert again? If I want to convert the number negative 10 here into the 2 complement, what do we have? What do we have here? If I want to convert the number 10 is the 8-bit memory, 8-bit memory of the 2 complement. What do we have here?
0, 0, 0, 0, 1, 0, 1, 0.
Okay, so number 10 again, right? You have 8. Sorry, you have this one, right? And of course, you need the 4-bit 0 here, right? Okay, so we look on this one. This one positive, right? And all of them here is number 10 here. And now, if I want to find out the negative 10 in the 2 complement here, what do I have here for this one? If negative 10, the first step, convert it to this one here. Now, the next step, you have to convert it into the 1 complement. Okay, so tell me what do we have? Tell me what do we have for this one?
Should be the 1, 1, 1, 0, 1, 0, 1.
Okay.
The opposite.
So now you do the 1 complement, right? This one is the side here, number 1, negative, right? And now you just reverse everything. You have 1, you have 1, you have 1, you have 0, you have 1, you have 0, and you have 1 here. That is a 1 complement. Now, in the third step, you add number 1 to the 1 complement. So now for this one here, you add number 1. You add number 1 here. See, 1 and 1, what do we have? 1 and add 1, what do we have here? 1 and 1, we have.
Would this be and or?
And 1 and 1, 1 add 1 here. In the binary.
1.
No, it's not any logic here. It's not any logic here. Actually, it adds together here, right? So basically, see, in the binary, right? In the binary, you only have the 2 numbers, 0 and 1. Right? 0 and 1 only. You cannot have the 2, 3, and 4, and 5. Right? So see, and 1, sorry, 1 and add 1 here, you have the 2. That means it's only overflowing, right? So basically you have 0 for this one, and you have the carry out 1 for this one. You got it? How can I explain it in the binary here, right?
So that,
So now see about this problem here, right? So now what happened here? What happened if you have, I'll see, right? So you have the 4 plus 9 plus 4. What do you have for this one? You have the 3 here, right? And it, yeah, remaining 1. What is it? 1 here is the remainder or what? Or carry out. What is the name of the one here? We call it remainder.
remainder.
Remainder. Okay. Yeah. So yeah, right. So we think that when you have 9 plus 4, you have 13, right? You have 13. Okay. But in the decimal system, you cannot put the 13 here because everything is only from 0 to 9 only, right? So this one here, actually you have to put 3 and the remainder 1 for this one. Now think about this one. 1 and 1 here, 1 and black 1. It overflow already, right? So we have to put 0 here and remainder 1 for this one. That's why you have 1 here, right? You have 1 here, and see, you have nothing. This one you have 1, you have 0, you have 1, you have 1, you have 1, and 1 here. That's all, right? And you do not have the extra bit for this one. So when you convert the negative number 10 here, you have 1, 1, 1, 1, 0, 1, 1, and 0 here. Or to make it simple, right? To make it simple, you just think about this one here. To make it very simple, you can think about this one. When you add 1 plus 1 here, 1 plus 1 in the decimal system, you have number 2, right? And of course, you can convert back to number 2. You have 0, 1. That's all. Or you can think about that. And plus 1, you have 0, and remainder 1, you put it here. Okay, the same. Okay,
that makes sense.
Okay. Mm-hmm. Any question for this one? Okay. So now to see that it's a 2 complement format can solve the problem of 2-way represent here. Now, through 2-way to represent number 0 here. Now, you see, that's the rule of the binary addition here, right? You have 0 and 1, of course, you have 1, right? And 1 here, you just keep it the same, right? Now, 1 and 1 here, see, 1 and 1, you have 1, 0 here, right? And so on, you see, and so on here. That's the way you work with adding here, right? Remember, whenever add 1 and 1, you have 0 and remainder 1 here, right? So for this one, you think about this one here. 1 and 1, you have 0 and remainder 1. And then 1 again, you have 0 and remainder 1 here. That's all. Okay. Now, now to see this one, define the 2 complement of 8-bit by integer, right? So see, when you convert from the decimal to the 2 complement binary, it's a positive. It only do the same. Just convert it normally, right? Just convert it normally and add 0 on the left. That's all. Right? But if you want to do with the negative here, right? The first thing you have to get it from the positive here, right? Positive here. Now reverse everything, right? 0 to 1 and 0 to 1 on 1 to 0. The next step here, you add it to 1. You add it to 1 here. So 0 and 1, you have 1 and 0 here. That's all. Right? So the negative here, you have the 1, 1, 0, 1, 0, 1, 0, 1 here. Any questions so far, guys? Okay. Now, that's a carry on, right? That's a carry on here, right? So is that carry on here? Yeah, I think it's a carry on, not remainder. So 1 plus 1, you have 0, carry out 1 here, right? Carry out 1 again. 1 plus 1, you have 0, carry out 1 here. 1 plus 1, you have 0, carry out 1 here, and 1 plus 0, you have 1 here, and so on. That is the way you work. I just came to the US on 2016. So many words I don't know how to say it here. Okay, of course, sometimes you cannot done in the case of overflow. In this one here, you see, it's negative 159, right? If you want to convert it to 8-bit binary here, so when you convert this one here, sorry, when you convert it into the binary, you have already it occupy all of the 8-bit here. You have no bit for the size here. That is some case you have the overflow. Overflow here. Now, to see if the zero solution can be solved by the two complement here, right? So now see about this one here. If I have all of the number 0 here, what do you have? What do you think? What is the number I have? 0, right? It's a positive here and constant. If I have all of them here, it's number 1. What do we have here?
0.
Why?
Well, it would be -0, but it's a complement.
Okay, now see how it works with this one here, right? So how is this one here? So to convert the order, so convert number 0 to this one is very simple, right? But now, if you want to convert the -0 here, right? The first step you have to do with the one complement, right? So we reverse all of them here. You reverse all of them. Now, the next step, once you already have the one complement, the next step you have to add to 0. You have to add 1. Right? So see, 1 and 1, you have 0 carry out 1 here, right? 1 and 1, you have 0 carry out 1, and so on, so on, so on, so on. The last one here, you have 1 here. Now, remember, when you work with the two complement, right? If it's overflow, you have to release the leftmost bit. You see, if you look on the rule here, if you look on the rule here, let me come back to this one. If you come back to the rule here. Now, if the result has each bit, you have each bit more than that bit, you have to discard it, the leftmost bits. Right? So see for this one here. So see for this one, you have the each bit for this one. Insert discard bit here. So see, actually for this one here, that is also negative number 0 here. And it's exactly the same with this one here. Okay. Right? So see, for the one number 0, even that is a -0 or +0, the way it represents the same. So basically, for the computer, in order to represent a negative integer number, you have to use the two complement. So see, so far you know that you have some of the way to represent the integer. Here, the first one is unsize, always non-negative. The second one is sign magnitude. The third one is a one complement, and the fourth one is a two complement. But the only two complements is the way you can solve problem of the 0 representation here. Right? Sign magnitude, no. One complement, no. Okay. So I think that's all for the part number 2 here, because you have something to do with the discussion, and you have to understand about the number representation in the computer here. Now I move to the slide. Since whenever I change it to the new slide, the problem happen again. Where's change? So I think so we learned something about the unstructured of spaghetti code. Spaghetti code that means everything was spaghetti when we mix everything together, and it's very confusing and very confusing with the spaghetti code here. That's why they call it unstructured here. Right? So basically, you have to understand. Basically, you have to understand the structure of the code. So basically, for every program, you have three basic structure here. The first one is sequence structure. Sequence structure, that means you do it on the order, right? From the first statement to the second one, and the third one, and the fourth one, and so on here. The second one is the selection structure. Selection structure, that means you have the decision structure here. Sometimes they call it decision structure. So in the decision structure, you always break it down into the condition here, right? And if the condition is yes, you do something. And if the condition is no, you do the other thing. Right? It is a selection. And the third one is the loop structure. Loop structure, that means, again, you have the condition to check. If the condition is correct, you keep doing it again and again and again, okay? And until the condition here is no. Right? Basically, for any program, it is a combination of all of the three structures. It is a sequence structure and selection structure and the loop structure. So once you understand the three basic here, sequence, selection, and loop here, now you just mix them up together, you just combine them together, you got the result program. Any program. Any program. Now, in the sequence structure, you perform the action or the task in the order. You have no branching or no skipping or any type. You just do it on the order from the first one to the second one and so on. Selection structure, break it down into branches, and you have the condition to check. And the loop structure is the repeat of action while the condition remains true here. Now, that is a sequence structure, right? You do everything in the order. The first one, the second one, and the third one. Now, that is selection structure. Selection structure, that means you have the condition here to check. Yes, do something, and no, you do the other thing. Okay, so in the selection structure, think about you can have the two of the selection structure. The first one is dual alternative. Dual alternative, that means you break it down into two branches. Yes, you do something. No, you do other thing here, right? So think about this. It's very simple problem with the selection structure here. Selection structure here, right? So we think about you have the program to get the age of the user, right? And the age, and you check the condition. You check the condition here. If age greater than or equal to 18, you bring now you are eligible to vote. If not, you are not eligible to vote here. So in the selection here, you always have the condition here to check. And the output of the condition is the Boolean value. And remember that Boolean value is only everything about yes or no, true or false, right? Only true or false here. So this work is very simple with a raptor here. So when you work with the raptor, so when you work with the raptor, in order to work with selection, you see you have this one here. That is symbol of the selection here. So we drag and drop inside, and inside this one, it's always the condition to check. And remember that the output of the condition here is only yes or no. Yes or no, right? It's only yes or no, right? So whenever we do the raptor, we can do with the selection here. We drag and drop and then put the condition inside this diamond here. Now, in some kind also you have the single alternative. Single alternative, that means you can think about this program here. If employee belong to the rental plan, right, then deduct 40 from the employee here. So if what happened if he is not belong to the rental plan, what happened? Nothing, right? You got nothing, right? So that is the case of the single alternative here. So in the single alternative, again, you have the condition to check. If yes, you do something. If no, do nothing. So basically for the selection, you can have the single alternative or dual alternative here. Okay, now for the loop structure, again, in the loop structure, right, it repeats a set of action while a condition remains true. If true, keep doing it. If true, keep doing it. Right? And also they call it the repetition or iteration here. The condition is test first for the motor program at the top of the loop, right? Or you can do the while do or the while loop here. It is a so think about this one here. So in the loop, here is a condition. Here is a condition here. You have to put the condition, and yet keep doing it. Inside that you can have many statements here, and keep doing it again. When you're done with iteration, you have to come over to check the condition again. If done with the iteration, you have to come over to check again. So if the condition remains true, you keep doing it, keep doing it, keep doing it, and it only exits the loop when the condition here is no. And in the interrupter here. So basically for this one here, let me go back to my program with the interrupter here. You can see how it works. Okay, so what's this one here, right? So is that you have work with selection here, and the condition here, I check if A is greater than or equal to 18 here. Right? So see, if I run it here, I put what is your age? I put 20 here, right? So see, when it's 20, what is the output of this one? What's the output of this one? If I enter the 20 here, what's the output? Yes or no?
Yes.
Yeah, right? So yes, it go with you are eligible to vote here. You see? Yeah. Now if I run it again, and this time I put the number 10 here, and you see the answer here is no, right? So we are not eligible to vote here. Okay, it's very simple with the selection here. Now with the call, sorry, with the repetition here. Now this one, when I work with the repetition process. So interrupter, when we want to do the loop, you see that is a loop here. It's a drag and repeat loop. Again, for every loop, you have the condition here to check. And this program here, I keeps asking the user enter the number, keeps asking the user enter the number. And you see, I have the prompt here, enter 0 to exit. Enter 0 to exit. You see, for every iteration of the loop, you always have to check your condition here. Is the number equal to 0 or not? Actually, one thing again I have to mention again here. One thing I have to mention again, the difference between the real programming language and the raptor. So basically, in the real programming language, whenever the condition is true, you keep doing the loop. You keep doing the loop. But in the raptor, when the condition is true, you exit the loop. Right? So that's why when you convert from the serial code or when you convert from flowchart, you have to understand the difference between the raptor and the real programming language here. Right? So basically, you see, in this raptor here, if I want to quit, I have to put the number equal to 0 here to quit, right? To quit here. So see, so every time it's just double my number here, right? It's just double number. So we see the structure exactly the same. You can see the structure exactly the same here. That thing you can think this one is the from input here. From input outside the loop, get the value in order to ready for the loop. You see, in this program, you need to check if the number equal to 0 or not. That's why you need to get the prom input, and prom input here is the number. And for every time you check the number here equal 0 or not, no, it's just double it, right? Print out the answer. Now, again, you need to move to the next number. That's why you need. So that's why you need this one here. Okay. So for this one, you see when they run it, here, I keep doing it, just keep doing it, right? So now think about, I have number 10, right? 20. Now see, ask me select number here, right? The 20 here. Now ask me for the next number. I have the 30 here. Now see, if I want to exit, I just enter the number 0 here, right? So when I enter the number 0, program come back to check the condition here. Number equals 0, right? Exit the loop here, right? Exit the loop here. So see, answer 20, 40, and 60 here, right? Now I will open this one and open this one with the Python here, so we can see the difference between the two numbers. So this one is a Python here, right? This one is a Python here, and this one the raptor. Where am I raptor? This one. Now, if you can see, it's also on the left it is a Python. It's on the left is a Python, and on the right it is the raptor here, right? So see, they work it quite the same here. It work quite the same here, right? You have to get the prime inputs. You got the prime inputs outside the loop, right? And in the Python, you have the condition. You have the while loop here. You have the condition to check if my number not equal to 0, keep doing it. You see, not equal to 0. But this one here, if my number equal to 0. That's the difference between the Python and the raptor. You have to remember that. In the raptor, whenever the condition is true, you exit the loop. But in the Python and in any other real programming language, whenever condition true, keep doing it. So that's why some of you make mistake when you convert from the pseudocode to the raptor. A little bit of reverse here. So the condition here, you have to check the condition here, not equal to 0, condition here equal to 0. Okay. So the loop structure, right? You can have the while, you have the condition here to check. If true, keep doing it here. If true, keep doing it this one. Now, for any program, remember that you only have the 3 basic structure. You have the sequence, you have the selection, and you have the loop or repetition here. Any program you can see, it's only the combination of all of the 3 structures. And for all of the logic problem can be solved using only the sequence, selection, and the loop. And structure can be combined to an infinite number of the way. And you can have the stacking structure. That means attaching the structure to the end-to-end, or and structure statement indicates the end structure, the and if statement and an if then else structure, and the and while statement and the loop structure here. So whenever you see the and if statement, if you have the selection here, if then else here. And whenever you have and while, you understand that is loop. Okay. Now you can think about this one here. You can think about this one, right? X1, you see, that is sequence structure, right? Now you move to the selection structure, right? And it moves to the loop structure. I see it's a combination of 3 structure here, that sequence, selection, and the loop here. Right? Okay, now any individual task or step in structure can be replaced by a structure. Now we have the netting structure. Netting structure, that means you put one structure into another structure here. In the whole another structure. Now think about this one here. You think about this one here. Now you put the sequence structure here, right? Step J, K, and L here, they are sequence structure. So you put the whole block of the sequence structure into the selection structure here. Right? So that's why they call it the netted. Netted, that means you put the whole structure, the whole block of the one structure into the another one here. Okay, so think this one here. Now, when you want to translate it, you only have to go from the inner to the outer. Right? So see, for this one here, you have the loop. You have the loop here. Right? See, you have the loop inside the sequence, and in the sequence here, you inside the selection. So when if you want to convert the structure of any program, you have to look from the inside. You have to look from inner, go to the outer. Right? This one you see if you look on this one here, you see you have the condition to check if yet going back. That is a loop. Right? So it's a loop. You put inside the step J, step L here in the sequence order. Right? So loop in sequence. Again, you see the whole sequence here, you put it in the one branch of the selection. So again, the sequence here in selection here. Right? Okay, so what do you think about this one? What do you think about the structure of this one? What is the structure of this one? Now, can you tell me what is the structure of this one? What do you think? What is the structure of this one?
Looks like a seek or an if then inside of a
Selection, right?
or selection.
Yeah, okay, selection.
Selection inside of a loop, inside of a sequence, inside of a selection.
Yeah, right. Selection again. So we have the selection here. This one here, branch here, selection. Because this one you see, the loop here, right? The selection inside the loop and inside the sequence. And this one inside the selection again. So you see, any problem you can solve by just a combination of all the three structures. Now, for the combining structure, the structure program has the following characteristics here, include only combination of three basic structure, any program. And each structure has a single entry point and a single exit point. Any structure only have the one single entry point and a single exit point here. And structure can be stacked, that means we put on top together, or it can be netted. It can be netted within each other here. But remember that for each of the structure, you only have one single entry point and a single exit point. Okay, now we come back to the using prime input to structure program. We learn a lot, right? We learn about the housekeeping here. We learn about the housekeeping. So basically, bring prime input here, the same. You can think about the housekeeping. The prime input is that you read the first input of data record. Remember when you learn about the when you work with the debugging exercise here. I think about if you want to get the mortgage payment for many employees, right? So get the name of the first employee, only the name of the first employee, and read the first input of the data record outside the loop, right? Because here, when you go to the loop, you only have the condition to check, and in order to have the condition to check, you need to get something before the loop. That's why they call it a priming input. You can think about the housekeeping here. It reads the first input data record. It's outside of the loop that reads the rest of the record and keeps the program structure. So from now on, when you work with this one, try to work with structure. You got the prime input before the loop, outside the loop, and you do everything in the loop. And remember, at the end of the loop, you need to get again to move to the next iteration. And analyze the flowchart for structure one step at a time. What for unstructured loop that do not follow the order here? First, ask the question, take the action based on the answer, and return to ask the question again. Okay, so we think about this one here. What do you think about this program? What's wrong with this program? Now, what is the prime here? What's the prime input here? What is the prime input? If you look on this program, what is the prime input here? Yes, original number. All right, now you check if the number. Think about this one here. Checks if the number not equal to 0 or whatever, or n of 5 here. Actually, for this one you have the 5. You have many numbers here, right? It's a 5. You have the number 10, number 20, and 30, 40 and 50. And when we reach the 50, it's the end of 5 here. The 50. Now see the program here. You got the original number 10. Now every time you multiply it by 2. It's multiplied by 2 and print out the number 2 number here. Okay, what else? What's wrong with this program? What's wrong with this program here? What do you say?
It's not asking for.
Yes, I see. So for this one, it only to get the number 10 here, bring down number 20 and stop. Right? And if you want to move on, you need to get the next number here. You need to get numbers. That's why also you need to get the input. You get the input number from the file here. So that is structure. You have a prime input before the loop. Get that before the loop. Right? And inside the loop, everything you done. At the end of the loop, you always have always need to get the input from the next number or the next statement in the loop here. The same, this one also, right? This one also. What's wrong with this one? What's wrong with this one?
Yes, it's still not calling for a new original
No,
number.
it's here. It's okay.
In the loop.
No, actually, this one it works also. If you work with Raptor, it works.
Because it's in.
Yeah, in reverse way, right?
Yeah.
So in the Raptor, it works also. I can see. I can show you how it works with Raptor here. But again, it's not good structure. It's not good structure here. So remember, try to practice that structure. That the prime input here, you have to put it outside the loop, and at the end of the loop, you need to get the new input here. You get the new input here. You can do it the same with this one. I think about this one. Now let me come back to my program here. Okay, think about this one. Yeah, good work. I see it working. No, actually for this one, I will put it before this one. It work. It work here, right? So we see right here. Number 10. And then I put 0. It work, but it's not structured. And actually, this one is only work with Raptor. In the real programming language, normally you have to check why and you have to check the condition first before you move on to this one, right?
Which is why you set it to call for that number.
Yes.
Outside of.
Yeah. In the Python, right? You think about in the Python, whenever you check the why condition, you only have the number here to check, right? So basically, it's Raptor, you can work with this one, but it's not structured. So do not use it in the Raptor, right? So remember that in order to do that, you have to bring the prime input here outside the loop, and at the end of the loop, you need to get the action to move to the next number here. Right? That is structure. Okay. So I think that's all for today. It's already 1:30. So yeah, so I'll see you guys on Thursday. Let's see what we have. Well, on Thursday, yeah, we do something with the Raptor function. Okay, so let me check the attendance here. Zachary Becker, are you here? Hello? No. Zachary Barrow, are you here? Camera, are you here?
I'm here.
Camera. Okay. You are here. Ridwan, are you here? Emiliano, are you here? Hello?
Here. Hello.
Okay. Riley, are you here? Kaden, are you here?
Yeah, I'm here.
Okay. Jasmine, are you here?
I'm here.
Okay. Luke, are you here?
Yup, I'm here.
Diego, are you here? Diego, are you here? Nick, are you here? Jack, are you here? Okay. Jose, are you here?
Yeah, I'm here.
Martin, are you here? Martin. Shalon, are you here? Nathan here. Aiden, are you here? No, he is already. Okay, so I see you guys on Thursday. On Thursday. Bye bye. Any question? Sorry, any question? No? Okay, see you.